So today I am going to start a new course that is on electricity, magnetism, EMT. EMT means electromagnetic theory. So before discussing this course, I am going to start with the basics of vector algebra. So I start with the basics of vector algebra, and here in this lecture I will talk about basic definition of vector and some basic definitions relating to it. So to understand physics, vectors play a very important role in various branches of physics. Physics like electricity, magnetism, electromagnetic theory, and mechanics. Vector analysis play a very important role. Vector analysis play a very important role. Generally, there are two types of physical quantities. There are two types of physical quantities. One is the scalar quantities and another are the vector quantities, right? So these are the two types of quantities generally with which we will deal in physics. So the quantities which have only magnitude and no direction are called scalar quantities. For example, mass, length, time, temperature, etc. These are the certain quantities which are having only magnitude but no direction. Now there are some other quantities. There are other quantities which have both magnitude and direction. And they're called vector quantities. Right? For example, displacement, velocity, force, etc. For example, displacement, velocity, force, etc. So to understand the concept of a vector, consider a block. Say it's a block, and say this is the surface, and say a rope is attached to it, and with the help of that we are pulling this rope along the surface direction, and when we apply some force over it, this block moves from this point to this point, right? So that means this rope is pulled along the surface, right? That means what will happen when we pull this block? It reaches from A point to B. Means when a block is pulled from A point along this direction, it moves, right? So that means a force acts over it along the horizontal. That means force acts along the horizontal. And then block move from A to B. So that means there is a displacement of block from A point to the B point, right? So this is represented by a vector AB, and it is represented like this. Say it is initial point A, and let me do one thing. Let us take this point is as A and this point as B, and this is known as tail of the vector, and this is known as head of the vector. And this is the initial point. A is known as from which vector started. It is known as initial point, and this point is known as terminal point. This point is known as terminal point. So that's what will happen. So this is a very simplest way to represent a vector, and this is a very beautiful example, right? Now, after the concept of a vector, let me talk about some basic definitions or some important definitions. So let me talk about some definitions here. So first is the unit vector. So a vector of unit magnitude, is called unit vector, generally represented as A cap. This is generally represented by A cap. This is the representation of it, right? Means we put cap over the vector. So mathematically when a vector divided by its magnitude, it is known as the unit vector. So this is the mathematical way of representing a unit vector. Now let me talk about another vector that is known as zero or null vector. Zero or null vector. A vector having zero magnitude, a vector having zero magnitude is known as zero vector. Is known as zero vector. A zero vector has no direction. Have no direction, and sometimes we call that it has arbitrary direction. Means its direction will become same as that when it is added with some vector, right? Then its direction will become of that vector. Then let me talk about negative vector. Negative vector, a vector having same magnitude, and opposite direction. Opposite direction to that of given vector. For example, say I am having a vector A, then another vector B is called negative of A if its magnitude will remain the same but it is pointing in the opposite direction, then this vector is known as the negative of A. Means thus vector B is negative of vector A, right? Then let us talk about another vector, that is co-initial vector. Co-initial vector. Vectors are said to be co-initial. Vectors are, means we are talking about more than one vector. Vectors are said to be co-initial when they have common initial point. Common initial point. Let us take a very simple example. Suppose I am having a block and one person is pulling it along this direction and another person is pulling it along this direction. That means first person is applying over force in this way and another person is applying force over it and in this way. Then these two forces or these two vectors, force vectors, are said to be co-initial. Means F1 and F2 are said to be co-initial vectors. Said to be co-initial vectors, right? And this point is at which these two forces are acting, and this is known as common initial point. Common initial point, right? Then let us talk about another definition, that is collinear or parallel vectors. Collinear or parallel vectors. So those vectors which have same line of action, or having line of action parallel, or having line of action parallel to the same line are called collinear vectors. Let us understand it by taking an example. Suppose I am having a vector A, and say there is another vector is C, and both are acting along this direction. That means this A and C have same line of action, or say I am having a vector is acting along this way, and say there is another vector, and these two vectors are parallel. So that means this A and B having parallel line of action, then they are said to be parallel vectors. And they are known as collinear vectors. Right, so this is a basic idea about the collinear and the parallel vectors. Then let us talk about equality of vectors. Equality of vectors. Equality of vectors. Two vectors A and B are said to be equal if they have same magnitude and direction. If they have same magnitude and direction. That is, A vector is equal to B vector, means this is vector A and this is another vector B. The magnitude of both the vectors will remain the same, and both are acting along the same line or parallel, and then they are said to be equal, right? Then multiplication of a vector by a scalar. It's a very important definition or important point which is to be discussed. So it is the multiplication of a vector by a multiplication of a vector by a scalar. Multiplication of a vector by a scalar. So consider a scalar n. When n is multiplied, means scalar n is multiplied with some vector a, then resultant vector b is equal to n times a, such that magnitude of new vector, that is b vector, becomes n times the magnitude of vector A, magnitude of vector A, that is magnitude of B will become magnitude of A, and the direction will remain, and the direction of B will be same as that of B. So for example, let us, I am having a vector A, it is pointing along this direction, then another vector B is twice of A, so it is pointing along the same direction as that of B, but its magnitude is double of this one, right? Also there is another more possibility. If say I am having a vector X, then a new vector is said to be 1 by 2 of X, say it is Y vector if its magnitude is half of this. Similarly, if we multiply with a negative vector, say P vector, it is a P vector, then if I multiply it with minus 2p, then this new vector q will be equal to like this. It is, but it is with the magnitude is the double, but it is pointing in the opposite direction. So this is a way to look at. Also let us consider few more points. So there are some scalars n and m. So for some scalar, if n is multiplied by this, then it can be written as na plus nb. Also if these are 2, then it can be written as na plus nma, right? So these are few properties of these scalar multiplication with some vectors, right? So this is all about today's lecture. So in the next lecture I will discuss few more definitions which are important in keeping in mind vector algebra.